In this video, we're going to take a look at section 3.3, which is on the elimination method for solving a system of equations. And here's how that method works. First, we're going to make sure that a variable will get canceled out when we add two equations together. So the first step is to pick a variable and make sure that variable has the same coefficient in both equations, but opposite sign. So one will have to be positive, one will have to be negative. Then you add the two equations together, combining like terms as you do so, and what should happen is that variable that we worked on in step 1 should get canceled out. This is going to result in an equation with just one variable remaining. And so we will solve the resulting equation for that remaining variable, and then take the solution from step 3, so whatever answer we get in step 3, we plug it back into one of the original equations to find the result for the remaining variable that was originally eliminated. All right, so that might seem like a confusing set of steps, but I think some examples will help clear that up for you. So let's take a look at some examples here. So we have these two equations. We have 2x plus 9y equals 65. We have 7x minus 9y equals negative 137. If you'll notice, step 1 is already done for me. I already have a variable with the same two coefficients but opposite sign, and that's the y variable, right? In the first equation, the coefficient for the y variable is 9. In the second equation, the coefficient is negative 9, and so they're the same number but opposite sign. That's exactly what we want to see. So step 1 is already done for me. So let's do step 2, which is to add these two equations together. All right, so this is step 2 here, and we combine like terms as we do so. And so we'll have 2x plus 7x, which gives me 9x. The y's cancel out. And on the right-hand side, we get 65 minus 137. Let me see if I have my calculator here. All right, because I wasn't expecting such numbers so early in the lesson. And so we get negative 72. So not a terrible result, but something I couldn't think of off the top of my head. And so step 3 is to solve the resulting equation. So this is my resulting equation. The y variable has been eliminated. This is why it's called the elimination method. And now we can solve this equation for x by dividing 9 from both sides. And we get x is equal to negative 8. So we have half of our solution to the system of equations. We need the other half, though. We still need to know what y is equal to. So to find the value of the remaining variable, we will take negative 8 for x, plug it back into one of the original equations, and then we can solve for y. So you get to choose which one you want to use. I think the top one looks slightly more friendly. The y is not negative. The coefficient of x is smaller. The number on the right-hand side is also positive and smaller. So the first equation to me looks like it'll be easier to work with. So I'll take x equals negative 8, plug it into there, and this is step 4. All right, and what we're going to get is 2 times x, which is negative 8, plus 9y equals 65. And then we solve for y from here to complete the problem. So we'll have negative 16 plus 9y equals 65. We add the 16 over to the right-hand side. And so we get 9y is equal to, I probably could do this in my head if I tried, but I'm not trying, so I just get 81. Divide by 9 on both sides, and we get y is equal to 9. And that gives me the solution to my system of equations. So my final answer would be negative 8, comma 9, and I would type it into this box here. All right. Let's take a look at another example. All right, this time, if we do the same thing we did in the last example and just start off by adding the two equations together, mathematically this is acceptable. You can do this, but it doesn't get you anywhere. So if I just add these as they are, I will get 5x plus 3x, which is 8x. I'll get 3y minus y, which is plus 2y. And on the right-hand side, I'll get negative 12 when I add those two numbers together. And so I get this resulting equation, which is true if 5x plus 3y equals negative 11, and 3x minus y equals negative 1. It's also true that 8x plus 2y equals negative 12. But it doesn't get me any closer to figuring out what x is equal to or what y is equal to. So this really doesn't do me any good. I make no progress with this. And so I might go back and look at the situation and think to myself, oh, if only we had a 3 here in front of the y. If they had just put a 3 there, things would have worked out just like in the last example, and the y's would have canceled out. But instead of wishing that we had a 3 there, we can actually make that happen. We can't just write it there, but what we can do, that's mathematically valid, is multiply the bottom equation by a 3 so that we get a 3 in front of this y so that the y's will cancel out. So I'm going to distribute a 3 to this bottom equation here. So the top equation is going to stay the same. We get 5x plus 3y equals negative 11. On the bottom, we're going to get 9x minus 3y equals negative 3. Now, and this was step 1, by the way, so that's making sure, adjusting the equations so that we have a variable with the same coefficient but opposite sign. All right, so we adjusted the bottom equation. Now we have this variable here with the same coefficient but opposite sign. So that's step 1. Step 2 is to go ahead and add those two equations together. So we'll get 14x. The y's are going to cancel out. And on the right-hand side, we'll get negative 14. Step 3 is to solve the resulting equation for the remaining variable. So we will solve this for x by dividing 14 on both sides, and we get x is equal to negative 1. So this is what I like about the elimination method. It really carries you pretty quickly to that first result, but then the last step, getting the second result, takes a little bit more work than it did with the substitution method. So now what we have to do is take this result that we just got, plug it back into one of the original equations, and then solve for the remaining variable. So we'll solve for y. I think I'm going to plug this into the top equation. This one's really, to me, hard to tell which one's the easier one to work with. I know these numbers are bigger, but there's more positive numbers here, so I'm hoping that'll make things a little bit easier on us. So I'm going to plug it into the top equation. So step 4, we'll have 5 times, instead of x, we're going to plug in negative 1 plus 3y equals negative 11. And now we will solve this for y. And this, like I said, takes a little bit more work, but in the end, it's about the same amount of work altogether either way. All right, so we get 5 times negative 1, which is negative 5. And what I'm talking about is whether you do it by elimination or substitution, tends to be about the same amount of work either way. All right, add 5 to both sides, you get 3y is equal to negative 6. Divide by 3 on both sides, you get y is equal to negative 2. All right, so my final answer is going to be negative 1 comma negative 2. All right, let's take a look at another example. Okay, so let's see what's going to happen here. Again, I have to adjust one of my equations because if I just add them the way they are, no variables are going to cancel out, and so I don't make any progress. I want to make sure a variable gets canceled out here, and so far, all of our examples, the y variable has been canceled out, and that's something we can certainly achieve here. So the first decision you have to make for step 1 is, which variable do you want to try to eliminate? And so let's go with y again. Let's make sure we eliminate the y variable. And what will I have to multiply here to the 6 to make it a 12 but negative, right? Because we want the opposite sign also. And what you're going to have to multiply by is a negative 2. So I'll take the top equation, multiply it by negative 2. That means I'm going to have to distribute it through the whole equation. And I'll get negative 10x minus 12y, right? So again, it gives me the same number as what I have down here, but opposite sign, equals negative 2. The bottom equation we didn't do anything to. We're just going to copy it over. All right, and this one you probably have already noticed by now something weird is going on, because now when I go to add these two equations together, so I'll go ahead and make it all the way across there. This is step 2. Our game plan was to have the y variable cancel out, which it does. But maybe what we weren't expecting is that the x variable also cancels out. So everything on the left-hand side of the equation cancels out, which means we have to put a 0 there as a placeholder because there's nothing there. And the same thing happens on the right-hand side too, weirdly enough, right? Negative 2 and 2, those cancel out. So we get 0 equals 0. So anytime you are solving a system of equations and your variables completely disappear on you, just like here, it's going to be one of these two special cases. Right? So you're not going to get a normal answer like you normally do with the other examples that we've seen. Right? So this is not going to be a normal case where we just get a solution. It's going to be a special case. But we have to decide which one is it. Is it infinitely many solutions or is it no solution at all? And the way you determine which one of those it should be is to see the result you get after the variables disappear. And the result I get here is 0 equals 0, which is true. And because it's true, that means this system of equations has an infinite number of solutions. If this had come out false, then we would say no solution. Right. So that one is a special case. So we saw this situation in 3.2 with the substitution method, that if your variables canceled out in that case, it was the same rules, right? If you got a result that was true, it was infinitely many solutions. If you got a result that was false, there is no solution. So it's the same deal here. We come across that situation in a different way, but once it happens, the rule is exactly the same. All right. Let's take a look at this one. Now this one I think is probably one of the more challenging problems in the homework, because getting a variable to eliminate is going to be a little more challenging here. So this time, what we've done in the past with these previous examples is we've changed one equation to match the other equation, right? So here I only had to multiply the bottom equation by 3 to get it to match the top equation, and then we were good to go. Here I multiplied the top equation by -2, but I did not have to do anything to the bottom equation. So again, altering just one equation. That's not going to work here. So whichever variable you decide to eliminate, you're going to have to actually change both equations to get the numbers to match up. There's nothing I can multiply to 4 to match it up to a 5, except for a fraction, which we don't want to do, right? So what we're going to have to do is change both of these and multiply them both up to a common number. It's very much like finding a common denominator. So if we decide to eliminate the y variable here, I want to make these numbers the same, but have one be positive and one be negative. So what's a common number that both 4 and 5 can be multiplied up to? The answer is 20. That'd be the smallest common number that they can both be multiplied to, which would be like a least common denominator. So how do I turn this 4 into a 20? I multiply it by 5. And so 5 times 4 is going to give me 20y there. How do I make this 5 into a 20? I multiply it by 4. 4 times 5 will make that a 20. And so we'll get these numbers to be the same. But we also want them to be opposite sign, which means I need to make one of these negative. I usually opt for making the smaller number the negative one. And so we'll multiply the bottom equation by -4, so that we'll get -20 for the bottom equation, but still have +20 for the top equation. And that way the y variable will be eliminated. All right, so let's go ahead and carry this out. Again, this is step 1. Multiply 5 through the top equation. We're going to get 25x plus 20y equals 5 times 52, which is 260. All right, for the bottom equation, we're going to multiply by -4, so we get -16x minus 20y equals 56 times 4, which will be -224. All right, so that's step 1. And like I said, that's worst case scenario, having to change both equations to get a coefficient to match up. Right? And so we get the y coefficients to match up here, and we get opposite sign. Step 2 is to go ahead and add these two equations together. So this is step 2 here. We'll have 25x minus 16x, which will be 9x. The y's cancel out. And on the right-hand side, we get 260 minus 224, which will be 36. We divide by 9 on both sides. And this is step 3. Solve that equation for x, and we get x is equal to 4. All right. Now we still need to find the y variable, so we will take x equals 4, plug it back into one of the original equations. Again, these are both equally difficult to work with or equally appealing, whichever way you want to look at it. So I'm just going to use the top equation. So I'm going to take x equals 4, plug it into the top equation so that I can find y. All right, so this is step 4 here. We'll have 5 times, in place of x, we're going to plug in 4, plus 4y equals 52. All right, and then we're going to solve that for y. So we'll get 20 plus 4y equals 52. We'll subtract the 20 to the other side. We'll get 4y is equal to 32. Divide by 4 on both sides, we get y is equal to 8. So my final answer here is 4, 8. All right, let's take a look at the next example. So here, these almost already match up. In fact, you see both of them almost match. So you can get a sense right away that something fishy is going on here. But they're not opposite sign. So this time we don't want to change the number. So again, let's say we're focusing on the y variable. You can eliminate x. I know that hasn't happened yet, but that is something you can do with these problems. Maybe we'll try that on the next example. But let's look at the y variable again. In this case, we have -6 here. We have -6 here. So they're already the same number. I just need them to be opposite sign. And so I will change the sign of, let's say, the top equation without changing the number by multiplying it by -1. So this is step 1, getting the same coefficient but opposite sign. We'll multiply the top equation by -1, so we get -2x plus 6y equals -3. The bottom equation we leave the same, 2x minus 6y equals 4. And now I add these together, and this is step 2, add the two equations together. The y's cancel out just like we were engineering it to do. But also the x's cancel out. So we saw this happen a couple of examples ago where all the variables are getting canceled out. So we get a 0 on the left-hand side. On the right-hand side, this time, however, we get 1. We don't get 0 again. We get something other than 0. So we're in the same boat we were a couple of examples ago, that all of our variables disappeared, which means it's a special case. It's going to be one of these two answers. And this time, the result came out false. Right? The variables disappeared, and we got something that was false, which means this system of equations has no solution at all. All right. Which means it's inconsistent, if it asks that, which I don't think it does. But all right. So I have a couple more examples for you of just, well, one of them is this case, which is a little bit extreme because of the fractions, but we're going to talk about how to deal with that here in just a second. And then I have a word problem for us to do, and then I think we're going to be done. So, all right. The first thing here is we don't want fractions to be here. I'd rather not deal with these fractions. You can leave them there, but it just makes the problem, 2 or 3 times more difficult. What I would recommend doing is get rid of the fractions by multiplying the common denominator to both sides. Right? And so we have 2 and 5. The common denominator for 2 and 5 would be 10. So I will multiply a 10 to both sides of this equation to get rid of the fractions. This has nothing to do with the elimination method yet. I'm not trying to get x to cancel out or y to cancel out yet. I'm just trying to get rid of the fractions. Right? We'll do the same thing to the bottom equation. Same common denominator. It doesn't have to be that way, but it was this time, right? 2 and 5. Again, the common denominator is 10. So we'll multiply 10 through the top equation. 10 times 1/2, that's just half of 10, which will be 5. So we get 5x plus 10 times 1/5. That's just like 10 divided by 5, which is 2. So we'll get 2y equals, don't forget to multiply it to the right-hand side. There's no fraction over there, but the rule for math is if you multiply a number to the left-hand side, you got to do the same thing to the right-hand side. So we get 7 times 10, which is 70. We do the same thing with the bottom equation. All right, so we'll get 10 times 1/2, that's just 10 divided by 2, which will be 5. So we get 5x here again. Minus, this one's a little bit tricky, but here's the shortcut. This is the way I think of it. When you multiply a whole number by a fraction, you divide by the bottom number, and then you multiply by the top number. So this will be 10 divided by 5, which is 2, and then 2 times 3, which gives me 6. And in case that's hard to follow, let me go ahead and just write it over here so you can see how it would work if you were, simplifying this on paper. Think of this 10 as 10 over 1. The 5 cancels out with the 10 and leaves me with a 2, right? That's 10 divided by 5, which is 2. And then you'll multiply across and you'll get 3 times 2, which is 6, over 1, which will just be 6. So the fraction goes away, and the result we get there is just 6y equals negative 90. All right. So that wasn't even part of the elimination method. That was, let's just get rid of the fractions from these two equations. Now let's talk about applying the elimination method to this system of equations. Let's pick a variable to cancel out. And just to do something a little bit different this time, and plus I think it's the easiest thing to do here anyways, let's go ahead and cancel out the x variables. They're already the same number. All I would need is to make them the opposite sign so that when I add them together, they cancel out. So I'm just going to take the bottom equation, and you can do the top equation too, but I'm seeing these extra negatives here that I can make go away as well. I'm going to multiply the bottom equation by -1. That'll make this the opposite sign of this, and plus it'll make these positive, so that we'll just have a bunch of positive numbers to deal with instead of a bunch of negative numbers to deal with. All right, so this is step 1. I guess I'll continue it down here. All right, so we'll have the top equation didn't change. We have 5x plus 2y equals 70. The bottom equation will be negative 5x plus 6y equals 90 when we distribute the negative sign through that. All right, step 2 is to add these two equations together. Oh, that was a really bad horizontal line. Let's try that again. Okay, there we go. The x's cancel out, just like we designed them to do. The y's, we combine those together, we get 8y equals, these add together and give us a pretty big number, we get 160. All right, so that's step 2, adding the two equations together. Step 3 is to solve for y here by dividing by 8. And so we'll get y is equal to 20. All right, so that's how we get y equals 20. And then step 4 is to plug this back into one of the original equations. Now here's where we're going to do something a little bit different also. The original equations had a lot of fractions, which I really would like to avoid. I don't want to deal with these fractions. So instead of plugging it back into the very original equations, I would recommend plugging it back into the original equations where the fractions have been eliminated. So these equations here are also our original equations, but it's been slightly modified so there's no fractions, and that's going to be an easier thing to work with. So I'm going to take y equals 20 and plug it into this equation here where there's no fractions. So this will be step 4. We'll have 5x plus 2 times y, which is 20, equals 70. And now I can solve this for x. All right, and so we will get 2 times 20 is 40. All right, and then we'll subtract 40 from both sides. We get 5x is equal to 30. And then we divide by 5 on both sides, and we get x is equal to 6. And that will be our solution to our system of equations. So when I go to type it into Math Excel, be careful about this, because we did things a little bit backwards in this problem. Not that it was backwards, but just the reverse order of what we did in the previous examples. That when I type it as an ordered pair, it's going to be 6, 20. So make sure, okay, let's try that again. 6, 20. All right. Make sure you put the x value first and the y value second when you type your ordered pair. Doesn't matter the order you got your answers in when you're going to type your answer. What matters is x value goes first, y value goes second. All right. So let's take a look at this word problem here. A woman bought some large frames for $12 each and some small frames for $6 each at a closeout sale. If she bought 26 frames for $216, how many of each type she bought? Okay, sorry, wow, there's this is kind of a really oddly worded question. So how many of each type did she buy? I guess would be a better way to put that. And also question mark, since it's a question. And so again, I apologize for the wording of this question. It's obviously, I snapped this directly from Math Excel, so that's something maybe they need to fix. All right, anyways, there's enough information here to do a math problem, even if the wording is pretty bad. So we have some large frames and we have some small frames, right? And so we have two unknowns. We want to know how many of each type did she buy. So we need to use variables, and we have two unknown values. And so we'll have two variables, which means we need two equations to have a solution to the situation. So I will let x represent the large frames, and I'll let y represent the small frames. And what we mean specifically about that is x is going to be the number of large frames. Sorry, supposed to be of there. Y is going to equal the number of the small frames. All right. So we need two equations now, and those two equations are going to come from this information here. This sentence, this not even a complete sentence, but the first part of this question here actually contains all the information we need to set up two equations. There's 26 frames altogether. So if I take the number of large frames and the number of small frames, the total number of frames should be 26. So that equation is simply x plus y equals 26, right? The number of large frames plus the number of small frames equals the total number of frames, which is 26. The other equation is going to be how much those frames are worth, the value of those frames. So if I take the value of the large frames plus the value of the small frames, it should add up to $216, the total value of all the frames together. Right? So it's going to add up to 216. Now sometimes students will do this. And they'll say, well, the large frames and the small frames add up to $216, which is the correct thought, but the details are wrong here. Because x doesn't represent the cost of the large frames. X represents the number of large frames. So we're using it correctly up here. We are not using it correctly right here at the moment. If you want to get the value of the large frames, you take the number of large frames that you bought times how much each one cost, right? So each of these large frames costs $12. So to get the total value of the large frames, it'll be 12 times x, right? And that tells me, so if they bought two large frames, that's $24 altogether, right? It's 12 times the number of frames you bought. That tells you how much money you're spending on those frames. Same thing for the small frames, right? They're $6 a piece, so I take the number of small frames I'm buying times how much each one costs, which is $6 a piece. And that gives me the total value of the small frames. And together, the large frames and the small frames have a total value of $216. So there's my two equations. And this section is the elimination method section. But this system of equations I really feel is easier to solve by the substitution method. And so I'm going to switch gears. I'm going to use the substitution method here because I think that's the easiest way to do it. So I will start by solving this top equation for one of the variables. I'll just solve it for y. It doesn't matter which one really. It's the same either way. By subtracting the x to the other side. So I get y is equal to 26 minus x. Right, that's the first equation. I'm going to plug that into the second equation. And so I will get 12x plus 6 times in place of y, I'm going to plug in 26 minus x. All right, so this is where the y variable was, but in place of y, I'm plugging in 26 minus x because that's what the first equation tells me y is equal to. All right, and this gives me an equation here of just one variable. And now I will solve for that one variable. So I will distribute the 6. Right, I'll get 12x plus another big number. A lot of big numbers in this section, huh? 6 times 26, which is 156. Minus 6x equals 216. I'm going to do a couple things at once here. Hopefully that's not going to be a problem for you guys. I'm going to combine the x's together. So 12x minus 6x, which gives me 6x. And I'll go ahead and subtract the 156 to the other side. All right, why wait on that? Let's just go ahead and get that out of the way. So we'll get 216 minus 156, which is going to give me 60. So let me just go ahead and continue up here. We get 6x is equal to 60. And now we will solve that for x by dividing 6 from both sides. And because of this word problem, we have to get a nice answer here, right? X is the number of frames we're buying. It can't be a decimal. It can't be 3.5. You can't buy half of a large frame. It can't be negative, right? You can't buy negative 5 frames. So we really have to get a nice positive whole number answer, or something's wrong either with the problem or with the way we solved it, right? So we get x is equal to 10, which is good. That's a good sign. which tells me the number of large frames, right? So remember, x is the number of large frames, so that's what I would type in here, 10 large frames. And then to get the number of small frames, I'll take x equals 10, plug it back into the original equation here. There's two of them to choose from, but this one's going to be a lot easier to get our value for y since it's already solved for y. And so we will get, let's do it over here, we'll get y equals 26 minus 10, which gives me 16. So in a moment, it's going to ask you, I shouldn't say in a moment, but once you type this answer in, it'll ask you for the number of small frames, and you'll type 16 in for that, because y is the number of small frames. All right, so that concludes section 3.3 on the elimination method.